Good morning, mathletes and film majors. It's Monday, August 6th, and it's the morning after. I'm here at the Jet Propulsion Laboratory.
All I can say is I picked a really great summer to work at JPL. So last night, or early this morning, we landed a rover on another planet. I'm sure you've heard by now, Curiosity has successfully landed on the surface of Mars. Everything appears to have gone smoothly from all the data that we've gotten back. There was a NASA live stream of the event as it was happening. Super exciting to watch, so if you haven't seen it already, I'd recommend you at least go and watch the last 10 minutes or so right up until the celebration part. I want to share with you my experience of watching the landing yesterday at Planet Fest. Turns out Planet Fest is mostly made up of JPL employees, SpaceX employees, and members of the Planetary Society. Which makes it interesting because a lot of the people in the audience had at least some work done on the rover, even though they weren't essential personnel that needed to be at JPL for the landing. It was also cool because it meant some of the people on the screen that we saw I recognized, and people sitting next to us recognized. Somebody would do something and they'd just be like, oh, Pete. They know those guys in person. Bill Nye was there to do the intro.
So thank you all so much for coming. We'll turn this audio back on and we will be on the edge of our seats.
Then we sat back, watched, and cheered as Curiosity landed on Mars. It was just a really great energy in the room. So now that we've landed on Mars, obviously the next question is, what comes next? Well, it'll be a couple days before they can actually start driving the rover around. First they want to do some tests and make sure all the instruments are working and that everything looks good. And then after 2 or 3 days, we can start driving around and making discoveries. The rover can only move about 8 feet per minute, which is not conducive to fast, long-distance travel. We've sort of landed on the edge of Gale Crater, and it's actually going to take about a year just to get to the base of Mount Sharp. To give you a little reference, after the first 4 years on Mars, Spirit had only traveled 4 miles and Opportunity only 7. The pace is going to be even more slowed down by the fact that these scientists landed in a pretty interesting area to begin with. They're going to find a lot of interesting things, and they're going to want to stop and take breaks along the way. One of the scientists equated it to taking a big family road trip, but taking 200 very curious scientists who want to stop and see everything along with you. So we have a long time to go before we're actually going to make any big scientific discoveries at Mount Sharp. The main goal of Curiosity now is to go and find some organic compounds, which could help prove that life once existed on Mars. They're hoping that much like the layers of the Grand Canyon give a good history of the water that shaped it, we will be able to see all the different things that have happened in Mars history. I thought I might address a couple of questions that I've heard from people about the live stream. First of all, what was with the Peanuts? So the Peanuts started in 1964 with the Ranger 7 mission. Before this, JPL had had 6 consecutive mission failures, or learning experiences, so everyone was really nervous. They'd sort of reached a critical point of really needing something to work. So on launch day, JPL employee Dick Wallace brought with him some peanuts that he thought would help calm people's nerves. And the rest is history. That mission went flawlessly. It's sort of become kind of a superstition. Every time they don't have peanuts, something seems to go wrong. Now, peanuts don't only appear at launches, they appear at any sort of large maneuver that they perform in the mission control room. Clearly, there's lots of evidence and logic that it does work. Yesterday only sort of enforced that belief. One other thing you might have heard is about tones. At one point they said Earth set over the Mars horizon and we could no longer receive signal directly from Curiosity. At this point we switched from telemetry to tones. You're broadcasting a carrier frequency which is being received all the time. Then on top of that you can add tones to say exactly what is happening with the spacecraft. You might have heard the term heartbeat tone, which is just something that they added to say yes, it's still working. Then there's also separate and specific tones for each maneuver that the aircraft would go through. So there's one for parachute deployment, there's one for skyplane deployment, there's one for touchdown, and that's how we really tell what is happening. You probably also heard a lot about Odyssey and MRO, the 2 satellites that were responsible for sending us data back from Curiosity. Odyssey did not start the night off in a great position. They had to perform a maneuver about an hour before entry that set up the antenna in the right direction to receive a signal and be able to send it back to Earth. They weren't sure if that maneuver was going to work, or if it was going to head over the landing site at the exact right time to receive data back, which is why there was some confusion as to whether it was going to be a couple hours later or just a few minutes. Fortunately, the maneuver was successful and we were able to get some data back immediately, as well as some really great pictures, although we weren't able to get high-resolution ones back for another couple of hours until it made its second pass. Oh crap, that's a secret one we're not supposed to show the public. There you go. Hours later, we received data from MRO, who at the time had just taken all the data and stored it to be sent back to Earth later. MRO also took a great picture once the parachute was deployed. And the thing that everybody's wondering now, how do we drive a rover around Mars? A few weeks ago, I got the chance to talk with the driver of Opportunity. Now, when I say driver, I do not mean that literally. Because there's such a big communication delay between Earth and Mars, if you were actually to be driving it in live time, it would be like sitting in your car, pressing the accelerator, and having to wait 4 to 20 minutes for something to actually happen. So instead of doing that, they spend the Martian night planning out what the rover will do for the next day. They give it very specific instructions, every minute is coordinated, then right before the rover goes to sleep for the night, it sends back all the data and all the things that it's done for the day, and then over the next Martian night, the scientists can determine what it will do for the next day. And for the next 3 months after landing, the team will actually be living on Martian time. Because the Mars day is about 39 minutes longer than the Earth day, it means that the team will have to keep moving their work time and sleeping times back. They actually have special watches made to help keep track of Mars time instead of Earth time. So 1 week you're working in the daylight, and 2 weeks later you're working in the nighttime. And then every 36 days you lose a day. There's actually 37 Earth days to every 36 Martian days, or sols. There's still a large media presence on lab as well. Lots of press conferences still to come as we get new data in. So there's still a lot of media on lab. More news trucks than I've ever seen. So the atmosphere in lab today was really great. Everyone had a smile on their face. Sitting in the cafeteria today at lunch, on one of the screens up, CNN was playing, and they came up with a story that NASA landed successfully on Mars, and every head in the cafeteria turns to look and just has this look of pride on their face that I worked on that, that's my rover. Many employees at JPL worked on this rover at some point in its lifetime, whether it be from the initial planning stage, or the software development, or the building of it, or the testing. So many people worked on this and helped make it happen. This was really well timed, because these guys are truly Olympians of science. The real discoveries are never the ones we expect, so I'm sure we're going to learn great things from this mission. For all the mathletes and NASA enthusiasts, I'm Susan. Caitlin will be back on Wednesday. Thank you everyone else for joining us.